Hello, everyone. I hope we are all having a great start to the day. We have Jarrod Marks today from Northern Adelaide Local Health Network, who is here today to present our first session. We are also going to provide his contact details on the chat for this session in case you would like to connect with him later or have any questions for him. And I still see attendees joining in. So, Jarrod, I'm going to pass it over to you. So whether if you would like to start or you give them another minute to for more attendees to join, up to you. Over to you, Jarrod. Thank you so much.
Hi, Pooja. Thanks very much for the introduction. Not sure I can see how many people are in the session, but I guess that in the context of time, unfortunately, I've got another meeting to go to after this one, so I will grab the opportunity, I think, just to get cracking. Just bear with me as I bring up my screen. All right, so everybody should be able to see my entire screen then. I think that should work. Hi, thanks very much for the opportunity to come and talk today. Obviously, I'm Jarrod. I'm the Chief Medical Information Officer at NARLN, which is Northern Adelaide Local Health Network. I'm probably not your usual doctor, and I think there's a conversation to be had. I spent the first 10 years of my life in engineering, primarily in industrial automation, before I did a science degree and then medicine degree, and I've been at NARLN now for 13 years, the first 10 of which were in the clinical life, and then the last 3 of which is the CMIO role. So as I say, I appreciate the opportunity to come and talk to you about some of the things we've been doing at NARLN. Yeah, let's try and get started. Apologies if that text is not great to read on your screens, but as I say, just a bit of an agenda for today. I'm just going to provide some context around, our approach to the use of knowledge graphs in particular. Some of the problems that we encountered in the implementations of large language models and conversations around, large language models, RAG, retrieval augmented generation, and graphrag. Thinking about some of the use cases and the things that we are using that kind of technology for, and then obviously the applications in particular of ontologies to graphs, as it was a key part of, what solved some of our issues. We'll have a look at, in particular, Neo4j_graphrag is a Python module, which I trust that some of you or many of you have had the opportunity to use at this point, and perhaps look at some of the gaps that it left for us in the development of some of our work. Then look at a modified pipeline that we created as a result. We'll sort of investigate some of the, maybe not so much the technical details as it is an understanding of the changes that we made to the pipeline to be able to actually sort of join those worlds of the technical components of graph to the clinical components. And then there should be an opportunity to have a demo and some questions at the end. So apologies that I can't see the chat. So I'll just kind of push on, and hopefully we'll have the opportunity at the end then to loop back on the discussion. Clinical decisions are complex, and as a clinician, as I said, we trying to deal with this idea that the decisions we need to make come from very a lot of different areas. We talk about the pathology of the actual disease process, the physiology itself, the combination of the two in the form of the pathophysiology, and then obviously when it comes to treatments and treatment side effects, things like that make decision making in medicine quite difficult. A key feature of this conversation then is that requires complex data and traditional models of data warehousing. Seems that we have a lot of our information in these, we'll refer to them as clinical silos, but the idea that our pathology information comes from a pathology information system, radiology information systems, and in particular clinical information systems in the form of an electronic health record. So today's conversation for us was about the idea, how do we actually make use of that unstructured text? Digital health has a lot of governance, and it's a very, very rapidly evolving space, and especially in the setting of AI governance and the advent of large language models and how we use them. Obviously, we're talking about this multi-layered considerations that we make around, personally identifiable information, ensuring privacy, security, and that there is appropriate governance in place. really important from the patient's point of view is conversations of consent, and that's not just the consent to capture their data, but the consent to use their data, and especially when we're using large language models and AI, it's a fundamental requirement where we share that information with our patients. Transparency and explainability are also a part of that conversation, and so that we've got to have an understanding of, particularly where we're using, something like a large language model for decision support, that we have some ability to actually try and provide some grounding in, okay, what or how, has it presented that information. And one of those key conversations in that explainability space is driven by the idea that we're very traditionally used to what I'll refer to it as deterministic, deterministic outputs from these systems, where large language models and sort of that non-deterministic output has raised some significant questions around the use of large language models, in healthcare. At a higher level, and I talked about those clinical information systems, is, what is the problem here? Obviously, on a day-to-day basis for us as clinicians, then we just tend to write our notes. We have this subjective view of what we write. We obviously use, language in quite inconsistent fashions, and it's that question of language ambiguity. I've used the example here on the right-hand side of, what is an MI versus myocardial infarction versus a heart attack. And in the patient context, they're all the same thing, but that's really, really difficult, to obviously get a computer to understand that they are the same thing. So at Nullen, we've got a combination of things, and I just wanted to put up front the idea of the use cases. What are we using this technology for? So that they kind of fall largely into three main areas, and so that when we're talking about this pipeline and our ability to obviously transform our unstructured text into meaningful clinical information that a computer can read, then we're talking about primarily summarization. And it's an unfortunate that one of my colleagues, Ashwin, was going to be presenting on the work that we've done in discharge summaries. He's not able to be here today, so I think that was unfortunate. But this is kind of this question of this is the underlying technology that we utilised in that discharge summary type work. The retrieval or chat type functionality, we're obviously looking at how do we actually put hands in the information of our clinicians more readily. So the idea that they can actually chat with the hospital's policies, procedures and guidelines. Okay, and then we obviously deal with this idea of then feature extraction. What does it mean to use the technology to actually look at and inform clinical best practice? It's a fundamental part of being a clinician that you engage in, clinical audit practices. And obviously, when clinical governance is concerned, the utility of it being able to extract information around what is the experience of our patients, what are they going through, how do we, adhere to what we see to be best practice from a clinical point of view. The journey for myself started about 12 months ago, possibly 18 months ago now, in that space of, okay, my first introductions for both large language models. Very traditionally, I'd used, natural language processing techniques up until that point. And obviously using large language models, I'm sure that like everybody else in the room, we've taken that journey of large language models into retrieval augmented generation, and then from retrieval augmented generation into graphrag. My journey in graphrag really started with that reference that Neo4j as an industry leader. This was the place of the thing. There's obviously the Neo4j_graphrag module, so the GitHub repository was released, and there was obviously some education around that by a lot of the Neo4j team. So I really grabbed onto that at the time and really started to use it. The simple knowledge graph pipeline very soon progressed into the manipulation of the pipeline and the components from within it. So this conversation of early use of the simple knowledge pipeline sort of made it very clear to me that, again, I had no control at all over what the LLM as a judge generated from the extraction from the text as far as entities were concerned. Okay, it was very clear to me that often it would fail, and so that there's a question of, I'll go back a step and also acknowledge that where I'd address that conversation of security, we had a fundamental requirement to be on premises, and so that a lot of our work was done with GPUs and CUDA, so that we always had that on-prem servers and quite a lot of GPU power to be able to do this, on-prem served LLM type functionality. So, as I said, I close out that conversation of my early work with the likes of Neo4j_graphrag. Really, we're limited by the idea that we had a lot of inconsistency in what the LLM would actually identify as an entity, how it would link it from the form of relationships. Obviously, as far as the pipeline was concerned, it was sometimes very difficult to understand where and why it would crash, and acknowledge that, okay, look, there is a fair bit of computational requirement there. My thinking at the time was centered around the utility of that. Okay, how do we actually, take our unstructured text? So, as I had alluded to earlier, as a clinician, I just write notes in the medical record. Patient X has Y, and we've done, A, B, and C, and we've got these test results and things that need to be integrated into the record. And then so our ability to extract that was also then constricted by the pipeline itself. So we had no real sense of being able to validate a question of provenance. And so that from that point of view, again, validation seemed to be a real sticking point for me, about having a sense of, both from an engineering point of view, how is the pipeline constructed? Where in the pipeline is is the pipeline failing? And then also then trying to actually, validate the clinical meaning underlying it. So in this space, and obviously in the setting of obviously some of the demonstrations that were offered, it was a still CIFO, and apologies if I've mispronounced their name, but had obviously flagged up some interesting work that was done around lupus, and I've recreated that again here today for the sake of the demonstration, to give people in the room the opportunity to build on their knowledge. But the conversation is there around that idea of that this made a lot of sense to me from an agentic point of view, the idea that I could then potentially build a graph that could be traversed by agents that had this normalized graph structure, where I could actually integrate many different documents. That was the key to the conversation around, particularly where I've looked there at the idea of the PPG, so that, that chat functionality, and how could I actually provide an interface to all of the guidelines. So if it was seen to be clinical best practice or things like that, we had a really readily, a really easy way for our clinicians to get access to information that we had seen to be best practice. So the central theme of which is obviously the underlying ontology. A little bit of research into the ontology, and it very quickly stood out that the UMLS has a lot of maturity. I can only comment to sort of post the development of this application, learning that perhaps the UMLS is not really the right one for choice in Australia, acknowledging that it doesn't actually contain the SNOMED CT AU and or ICD-10 AM. Components or vocabularies of the ontology. So the missing pieces from the point of view of that graphrag, I've already kind of explained. We were stuck with the idea around validation. We were confined by doing on-prem computation, and so the limitations of, at that point, Llama 3-ish. Llama 3 had just been released, and then obviously how we would serve that. Llama CPP had some maturity. A Llama had just come along, and then subsequent to that, we've kind of moving towards a VLLM space. So I know that may not mean a lot to the non-technical people in the room, but again, I'm open to taking on board both questions from both the technical side of the things and also the clinical side. As I have then talked about then, is provenance tracking was fundamentally important, and I've talked about the UMLS integration as a part of that ontology. So again, this is kind of the basic Neo4j_graphrag, and it very quickly evolved into the model that you see on the screen now. I'm not going to spend a whole lot of time sort of describing all of the elements of that, other than to acknowledge those that I've indicated in red are usually custom modules that I've built that either extend the underlying Neo4j_graphrag modules, or are just genuinely custom modules that I've built myself. The V's, the red ones, are obviously indicated then by validation steps, and those we'll go through in a bit of detail. We talk particularly about the named entity recognition as the extractor validator, which is obviously seen here as V4, and then obviously the medical validator that's a part of V6. Up here in the top right-hand corner is obviously the UMLS, and so that I've obviously built a cached form of the UMLS that will actually interface to the API in the absence of things. Obviously, it was a significant bottleneck early on to be interfacing to the API endpoints, and so that caching the actual UMLS in a structure that I could actually manipulate was really quite sensible. So, as I said, we'll start with the the UMLS entity and have a bit of a description of what it is. So, as an ontology, it's maintained by the US National Library of Medicine and has been around for a very long time. It's made up of three main components: the meta thesaurus, which is the overarching things that actually links together the semantic network, acknowledging that there are many vocabularies. I've used SNOMED-CT and ICD-10 as the main two vocabularies in this particular instance. But as I had alluded to earlier, look, I've come to appreciate that it's not really appropriate then for use in Australian healthcare context. We used obviously the SNOMED-CT AU and ICD-10 AM as the two standards in Australia. That semantic network we'll explore a bit, and the lexicon I haven't had a lot to do with, but it just acknowledged that as a concept, the UMLS maintains a set of natural language processing tools, and so that idea of lexical analysis and things of that nature that are applied to that semantic network are a thing. So the meta thesaurus is that parent, basically a database of all of this, medical and biomedical health related concepts and terms. I've used the two meaningfully because we've got the notional concept of a QE, so a concept unique identifier, and then a TUI, a term unique identifier, and so that those two parts actually are built together to describe the entity objects, and then obviously how they are related to one another. So to just loop back to the conversation around, the difference between myocardial infarction, MI, and heart attack. And so that we have this idea that from within the meta thesaurus, with all of those vocabularies considered, they all get integrated. It obviously gives a very useful tool with a great deal of utility for validation. So we have this idea of a very clear structure around what are the entities, how do they relate to one another, both in a vertical and or horizontal context. The other part of that, in the context of that lexical analysis, the idea that we actually can disambiguate. So the named entity disambiguation component of it is quite clear when we're talking about conversations around synonyms, acronyms. Okay, and then obviously trying to draw out those conversations of the relationship. The semantic network that underlies that meta thesaurus is actually doing exactly that. It describes, as we say, 135 odd categories for entity types. I've just highlighted diseases or syndromes for the example here because, again, I've just have run a couple of documents, through the pipeline this morning or late last night with the view that, okay, look, I'll just try and explain some of how am I actually using that validation and what does that validation look like. And then, as I had said to you, then the semantic network obviously also defines those relationships. Again, great deal of utility around, being able to validate that we have a known sense that, okay, look, a drug treats a disease or a virus causes a disease or vaccines or other treatments or things. And so that the notions of entities and relationships makes it actually a really meaningful validation tool for the production of graph. Coming back to named entity recognition and named entity disambiguation as a function of that, as I said earlier, I spend a lot of time in the space of obviously trying to get our on-prem Llama server to actually give me back a meaningful. The pipeline process was one that, as I say, particularly early on, acknowledging, as I had said, that it was 12 months ago. The technology's come ahead in leaps and bounds over that 12-month period, but it does acknowledge, as I said early on in the piece, I really struggled with kind of JSON object extraction. How do I actually normalize the output of the LLM? How do I put it into a format that I do? But I think, as everybody in the room would appreciate, for those technologists that are here, that, it's come a long way. And so that I don't think I would be having, either investing the amount of time that I did or needing to solve the problems that I I've had to do before. But it just, as I said, rallies around that idea. So, oops, sorry, let me go back. And I just want to move that one out of the way. So at a high level, it wasn't to be about the technology. If the bottom flowchart is probably more prescriptive, and just in the interest of time, I'm not going to spend a lot of time on the technical part of it, but acknowledge that the workflow is quite clear. I was using the lexical component of the Neo4j underscore graphrag to actually take the document and then parse it into chunks, and then obviously the embedding component was obviously served up by an alarm call. We've got the extracted chunk is then passed through as a JSON string. We obviously pass it into this validator just to extract it and obviously make sure that it's normalized. I'm sure that for those of you experienced in this space will recognize it as a Neo4j graph output. So obviously as far as the pydantic classes are concerned. But as I had said to you, look, we put a lot of work into that world in which we were getting large language model output. We were needing to put it into a format that we could use and then pass that on. From the point of the NED, then, as I said to you, this was where we started to do that interface, and up in the top right-hand corner was exactly that, our interface to the UMLS service through the named entity disambiguator. And obviously where I was caching information, but again, that sort of workflow is described down the bottom, where we've got these entities that are extracted by the LLM, are passed on to a UMLS search and validated against them from the point of view of the entity itself. We've got then a stage 2 component which actually takes them. So we talked about that idea of MI, heart attack, myocardial infarction. So you recognize that even if they are extracted by the LLM as an entity, then we have a way of normalizing against those to actually find, we might refer to it as the canonical entity. All right. And so that's where that QE-based merging is occurring, is the idea that whatever is extracted, if it does exist in the UMLS, it gives us a way to actually map it. Wanted to be clear about conversation, particularly of provenance. We were kind of pretty rigorous in this world of, okay, look, where did it actually come from? What have I transformed it to? What is it going to look like as I pass it further down the chain? Moving back to a conversation around validation, and as I had alluded to earlier, we've got kind of this, I took this view of type 1 and type 2 validations, because it kind of, as an engineer, you get stuck with the idea that validation of the pipeline data quality, what does it mean to actually parse data back into a JSON format and be able to hand it around appropriately? Obviously, that earlier parts of the frustration about, we're not knowing where in the pipeline it was crashing, what is it doing? So that, applying high degrees of rigor to, to validation as we walk down that pathway. So looking at the loader and obviously which documents are loaded. Okay, looking at the chunks and making sure that the text that's extracted in the chunk is not empty. Looking at the embedding and making sure we've got good coverage of the embedding functions. Looking at the extractor and then making sure those extractors are done. And then obviously, as we had shown in that pathway around named entity disambiguation, that the medical validator is a significant part of that conversation. So that I'd established a couple of different pathways around, particularly that stepwise progression down the pipeline, acknowledging again, what did I want to do with it if in the event that it thinks, did I want to let it through? Do I want to actually action it now and keep the actual pipeline running, or do I want to be able to dump the pipeline and start from scratch? Same applied, or same kind of thinking applied to the medical validation or the UMLS validation, to make sure that the information that's traversing the pipeline is actually clinically relevant. So that idea, and again, we've described that in that higher level path flow diagram, but again, reiterating the sense that, okay, I've got this sense of the entity, I'm matching it against the ontology, and then I'm actually placing it into one of a couple of different modes just to ensure that it's actually a meaningful entity. And there's a bit of an abstraction that I'll show you around the idea that this is still only in this, the dealing with the pipeline as a single document extraction, so that we'll look at validation from that higher level in the demonstration. But that was kind of where I had sat with that idea of validation and just the importance of that validation, in that pipeline. So with all of that considered, how are we going to use that data model? It was obviously a case of graphrag. So I did very much, having sort of built what we refer to then as a normalized model that actually uses these concept unique identifiers, and we've already built them into a graph, then it gives us that ability to actually take in multiple documents and then refer to it as, comparing apples. then our ability to do that and how we would apply that just required, again, just a, was just extending the actual, the Neo4j graphrag things and using that medical context, using prompts and prompt engineering to actually index against those, concept unique identifiers that are fed through from the UMLS. So walking down that same pathway, as you say, it's a very similar thing to normal graphrag. We're talking about taking in the query, embedding the query, using cosine similarity function to do a comparison, obviously acknowledging the provenance that was embedded into the graph, making sure we carry that provenance forward, then passing all of that information to the LLM to generate a response. So if I can switch screens now, I have got the demo up. I'll just try and maximize that one for the sake of the conversation. In the interest of time, I was just keen to make sure that, I sort of pre-prepared the query. Obviously, we just said, what are the treatments that are effective lupus nephritis? It's obviously come back and, replied with a response that acknowledges that, okay, the information isn't about specific reference, but it is about the context that was loaded. So note the answer is based on the provided context. And so in that fault finding process or that validation process of me kind of confirming, one, that my pipeline did what it was expected to do, I just made sure that the citations that were carried forward, we had the ability to actually go and mine them, take them out of the graph database. We have a clearer understanding of, what is the text that's actually contained within the chunk. Okay, and then what are the entities that are extracted from that chunk, so that I could clearly correlate the idea of, perhaps it is a question of cyclophosphamide or the other treatments that are a part of that. So hopefully that gives you a bit of an understanding then of, again, this idea that was just really kind of rigorous in the way that I wanted to be able to validate what was extracted from the text. Can I validate that it's extracted all of the meaningful clinical information? When we're talking about the validation, as I say, this kind of level, again, I had sort of built in that idea of, as I had described, we've got single pipeline runs, and so that they obviously iterate over a single document, chunk them up, take the entities, extract them, and then place them in the graph. What I wanted to be able to do then is understand, okay, from that single pipeline extraction, are there ones that are now mismatched? And so that there are two functions of that is duplicate entities and how they're represented, so the deduplication of it. And so I just sort of built in this functionality that would actually give provenance to the idea of a merge and what does that looks like. One is identifying a canonical entity that we would refer to, and then what it actually does, and I can probably give a little example of that in the graph. Well, I'll have a look at that shortly. Is obviously where I can identify the entity. So even if I do it this way, I've got a few funky ways of going about that, and I might just oops. Okay, and then we were back here at this conversation of, let's just take that one. So I've identified the thing, and can I find it in the graph? And so even if I simplify the query back, and so I have this relationship of those entities. There might be, relationship will be, I think it's merged from memory. Yeah, I'm surprised that didn't show that, but again, we have this idea of duplication. Oh, maybe it's to do with I know what it is then. I've only merged one. This one hasn't been merged. Maybe I can merge it and just use that as an example. That's the labeling. Now, apologies. I don't think it's probably just in the interest of time that I just let myself go down the rabbit hole, but I have to acknowledge then that, as I say to you, I have built into this system the idea that I can actually look at, type mismatches and obviously reconcile those across multiple parallel runs of the thing. Here's kind of that broader view of the example. We've got some documents. They're obviously chunked up, and like it shouldn't matter where I grab them. We should be able to, sort of deal with the idea that, our chunks are actually matching across those documents, despite them being quite independent documents. And I was going to sort of give that demonstration that these are the two papers. They're kind of just papers around the SLE. For clarity, these were papers that were utilised by previous Neo4j underscore graphrag, sort of education sessions. So again, I'll just sort of encourage people to, look around a little bit, and you'll probably find the same model out there. As I say, just again with this idea that I've just extended on that for the sake of, providing something that I can see that, provides more utility in the clinical space. I think that's probably all I had then to demonstrate. Just let me, if I flick back to the demo, we've talked about the actual SLE topic, as in I'm just bringing together a couple of documents about lupus, bringing them into graphrag. I've showed you evidence of the provenance, and then the validation. Probably didn't do a great example of that, but it really was about our ability to actually look at disambiguation from the point of view of having, actually I probably didn't show that fantastically well, this is this conversation of here that, okay, look, we've identified in the graph and the way that the LLM has generated is extracted belimumab as a treatment. But when comparing that to the actual underlying UMLS, and UMLS is recommending that it should actually be stored as amino acid peptidoprotein, a pharmacological substance or an immunologic factor. And so that's where I've just, again, being able to apply these actions to it and say, hey, do I want to delete the one that the LLM gave it, and then apply these ones which are more in keeping with, the UMLS and how that's going to be applied. So I think that was the example that I probably wanted to bring out. So wrapping up, key takeaways, obviously clinical language is ambiguous, and so that, your requirement to normalise it with the UMLS, again, I'm not clear that the UMLS is the best one for Australia. Again, there's probably work to be done, at a research level around the use of SNOMED, CTAU and ICD-10-AM. Healthcare language requires validation and provenance, not just extraction. Semantic interoperability requires ontology integration, and extending existing tools like Neo4j graphrag rather than reinventing the wheel yourself. Couple of key graph resources. As I said, my journey of probably the last 18 months or so was driven initially by Estelle Seifer, who was the person who, if I understand it, she works for Neo4j. I'm not clear on where she's at, but I just wanted to be, kind of give appropriate acknowledgement to, where I'd learned, because I think I found this to be a great resource in that introductory space for those of you that want to get into Neo4j underscore graphrag module and how to use it. She's obviously published a few books on Neo4j, so hands-on graph analytics and data science with Neo4j, which is published under PAC. And Tomas Bratanic, and apologies that again if I've misspelled his name. I do notice that Tomas is actually presenting here at Nodes, so again, grab that opportunity. Essential graphrag, I don't know if you guys are familiar with the Manning Early Access program, but as he wrote Essential graphrag, I was kind of following along. So again, a very useful way to access, this information earlier, and again, highly recommend, utilising those types of resources. At a high level, as I say, there's obviously the UMLS and obviously access to the API-related information. And then we've used Llama a lot because I think it's simplified the process of API from the OpenAI API endpoint, so you can actually interface it through more traditional sort of open, ChatGPT type interfaces in Python. Obviously, when it comes to structured outputs in JSON, I think again that's improved that scenario significantly from when I'd originally done the work. So again, highly recommend that people look into that space. Here's me as I close up. And if everyone's happy, as I say to you, you're welcome to reach out to me on LinkedIn or just send me an email if you've got any sort of burning questions. I'll flip back to the presentation and just see if there's any any questions that anyone's got. I'll stop sharing my screen for the sake of
Thank you so much. Hey, thank you so much. And well, that brings us to the end of this particular session. Thank you so much for your patience, everybody. A survey has been posted to collect your feedback, and we'll see you all in the next session. Take care. Bye-bye.